ML. I, Mrs. Sankirti Shiravle, coordinator of this STTP, take this opportunity to introduce Mr. Atul Bengeri sir, an eminent speaker of this session. I welcome you, sir. Mr. Atul Bengeri, a versatile personality with over 22 years of experience in IT industry with focus on digital transformation in the healthcare, enterprise, education and government verticals. He had shown he was associated with many top-notch organizations such as Dell, Siemens, Intel, and now he has established himself as a successful entrepreneur. He is founder and director of Acumen today, Pune. Sir is digital transformation trusted advisor and influencer with a distinctive advantage of working on latest technologies of IT infra, data center solutions, cloud, big data, IoT, and AI in the healthcare. Sir is executive and founder member of Society for Data Science. As part of the founding member, he has been propagating the nuances of data science across academicians, corporate, and student community across a few countries through various technical programs, sessions, seminars, and conferences. He has conducted over 30 plus workshops on big data, data science, data modeling using statistical methods, and R programming. We are honored to have you with us, sir. Now, I request Mr. Atul Bengeri, sir, to enlighten today's gather. Over to you, sir. Thank you.
Thank you, Sankirti madam. What a pleasure to have you introduce me, and thank you for the warm welcome. It's always a pleasure to be associated with academics and the good work that you, your team, and the institution that is into. So, without much of ado, let me start presenting my presentation. We straight away get to the topic. And for doing that, to conserve on the bandwidth of everyone, I'll stop my video and I'll go to the presentation. Will it be? Yes. Okay, there you go. Oops. Yes, just to confirm that you're all able to see my screen.
Yes, sir.
Okay. So the topic is very interesting and very large and vast. When we talk about artificial intelligence and machine learning, they may look to be in silos, which is true when we look at it at a micro level. But when we start looking at it at a macro level, it is very evident that one cannot be looked at in silos, neglecting the other. Each one complements and supplements the other. So having said that, let's straight away get to what it is. And this is the topic, AI ML application with big data. And just to put it across that you know whom you are listening to. I am a thought leader from the Open SAP background for creating trustworthy and ethical artificial intelligence. Why is this important? Is because when we talk about artificial intelligence, the most important aspect that gets neglected is the ethical nature and approach of using the data and applying the artificial intelligence on the data. It is very easy, very simple to put it to wrong use, but it is a conscious decision of all of us, educators and thought leaders like you and me, who need to be looking at the ethical side of it, which is paramount, and not get diverted into something that is easy and against humanity. So having said that, being future ready, it has its own importance. And when we talk about this particular field, we're talking about the challenges that we are facing, which is growing population, which brings about the safety and security demands of what the population needs. and then to bring about the affordability and the comfort and the livability factor for each of the person living on this planet Earth. So that's why I say it has never been as important as today. And the situation that we are in, the pandemic situation, has actually manifested it and extrapolated all of this that I am talking. And then the thriving culture, innovative ways of creating and consuming demand. It is not just creating the demand, but also consuming the demand, which we will go a little bit deep dive when we speak about the topic. And then, of course, the new and innovative business models. So the question that comes to our mind is whether technology is providing all of this or whether business is driving technology, which we will look into as we go forward, and which will also lead to a lot of economic opportunities. I've picked up education, which is mainly to focus on the core and the skill set needed for the future jobs. So being future ready has never been so important, especially in the times that we are today, because of various different reasons, some of it which I have pointed out. And when we talk about job creation, yes, there is job creation, but at the same time, there is also that the jobs are being replaced. The jobs of yesteryears are no more jobs that would remain today or going forward, mainly because of the advent of technology, proliferation of technology, starting from automation to robotics to artificial intelligence and machine learning. So there is a shift in the jobs that we are experiencing, and that is where the reason for all of us, or the motivation for all of us, to be future ready. And having said that, machine learning and artificial intelligence go hand in hand. Though we may want to look at it in various different aspects and various different means, but looking at it in a holistic manner is what will bring the benefits of it. And that is what we are here to talk today. And how is artificial intelligence impacting our lives? It is impacting in every walk of our life. A few of it which I have put across, which could be from the banking and financing sector. That is the first one to actually implement anything new, especially in the new technology advancements. And of course, going forward, we are talking about driverless cars, automation, autonomous vehicles, smart homes, security and surveillance, and of course, the e-commerce boom that is happening for quite some time now. So we're going to talk on some of the use cases as well, but I'm just preparing the background and putting across some facts and figures, because artificial intelligence and machine learning has no meaning if we don't talk data. And what better way of putting this across in terms of the business sense? So look at these numbers. 300% increase in the investments that have happened on artificial intelligence. And this is happening even at a faster pace today. 57% of businesses, they expect it to help improve the customer experience. Have options today to look at various different products and services. And that's where the aspect of consumer analytics, or analyzing the consumer behavior from the seller, is very, very important. And that is where 57% of the businesses are expecting that artificial intelligence will be the next big thing that will help them in understanding this better. 20% of major retailers across the world will use artificial intelligence to personalize the brand experience. So 20% of the retailers, the retail shops, the small shops, the big ones, the malls that we all see, of course, which are all closed today, but they all feel that 20% of them are seeing that artificial intelligence will help them in personalizing the brand experience that you and me will experience going forward, which will also help in creating the branding, the brand awareness, and the brand loyalty. You may think I'm talking non-technical, but unless and until there is no business sense to what technology can provide, each of them cannot coexist. And unless and until they cannot coexist, there is no use of either of them going forward. So while we know that machine learning, artificial intelligence, data science, and big data are going to play a big role, is it validated from the business's side? And these figures, these numbers actually talk about it, which is actually very encouraging. Coming to the workers side of it, 20% of all workers will use automated assistance technology to make decisions and get work done. This is an advantage as well as an opportunity, as well as a scary thing to look at. If 20% of my work will be automated, what would happen to those people who are presently working in that particular segment? So automation is definitely going to be the next big thing that's happening. As I mentioned earlier, automation and robotics are going to take away a lot of our jobs, but at the same time, they're going to create new jobs. The mundane, repetitive jobs would all get replaced. We don't need human beings for doing a job which the machine can do better, right? Look at it that way. We can't be looking at the 20% jobs being cut off. We need to be looking at the new jobs that would get created, which would be in excess of this 20%. And 80% of the executives, the top executives across all different brands, say artificial intelligence boosts productivity and creates new positions. Oh, yes. So, what are we actually deciphering from this slide is that it is going to be data driven. And when it is going to be data driven, artificial intelligence and data analytics is going to play a major role going forward. And what better theme than this for this particular session? I want to take your attention to something that has happened in the recent past. And I would want to take you to 2000, which is 20 years back, and then come to 2020, where we are now. The technology roadmap of the Internet of Things. I can't be looking at artificial intelligence and machine learning and big data in silos without having known the various different routes and the various different sources of the data. And Internet of Things, the IoT, plays a major role in it. So what is IoT in total? This slide actually talks about IoT. So in 2000, we were gung-ho about using RFID tags. We were gung-ho about using chip-based tracking mechanisms for not just financial transactions, but for a lot of logistics and supply chain management. Now that demand was not just in logistics and supply chain, it got manifested into a lot of new use case models as we started growing in our demands and growing towards new technologies. So by the time we progressed to 2010, we started talking about safety, security, surveillance, document management. Wow, okay. Now see how just the RFID tags got translated into something beyond just tracking and routing, into surveillance, security, transport, food safety, and document management technologies. Right? So what does that mean? It means that the devices started to become more intelligent. Ability of devices located indoors to receive geological signals. Sitting in my office, I would know exactly where the container is or where the shipment is because of the way in which I am tracking it. It started off with simple barcode, then through an RFID tag, and then we are talking about IoT devices, which would be a combination of networking, communication, and compute capabilities. which led to locating people and everyday objects, which is mainly in terms of the GPS, GPRS services. And what are we talking in 2020? We are talking about teleoperations and telepresence, ability to monitor and control distant objects, the conglomeration or the cohesion of the physical and the digital world, which we also know is Industry 4.0. So nothing of this can be looked in silos because technology is ubiquitous. Technology is shaping up the world. Technology is showing the world what next. And it is the software, the hardware, the networking, the communication, the devices, the new use case models, and the businesses around it, which makes the difference. And there we are. We talk about industrial Internet of Things and the consumer Internet of Things, which are both put into use in large proportions as we speak. I'm picking up a few as use case out of this, but for all of us to know that we are all part of the Internet of Things revolution, Industry 4.0 revolution, whether you want it or not, whether you know it or not, we are part of this industrial Internet of Things and consumer Internet of Things revolution. That's where it comes to saying making sense from sensors. So making sense is the artificial intelligence, and the sensors are nothing else but my Internet of Things, which are today independent, interconnected, and intelligent devices, all put together, what we call on-device intelligence, which is mainly not just collect and transmit, but also collect, collate, compute, and then transmit. So you have the edge computing coming off late, which is talking about doing the analysis at the source of collecting the data. Okay, now how is all this connected to the topic today? Let's go a little forward. Now, if we talk about all of this, look at the amount of data that gets collected. Drone technology all of a sudden is the in thing. Everybody is talking about drone, connected cars, autonomous cars, independent, intelligent devices, so on and so forth. The wearables. Yeah, we will talk about a few of this going forward, but I want to bring in the focus on big data as well. When I talk about the sensors and the IoT, I cannot be behind when I talk about big data. See how each one is connected. I'm not going into all the 3 V's or the 6 V's or the 8 V's, but big data is what is driven by the revolution that we are seeing in terms of data being collected. Rewind back 20 years, and we were all having a challenge of no data availability. We have all spent our lives in creating systems that would collect the data in the first place. And now is the time to actually start looking at what would you do with the collected data? What would you do with the various different ways in which the data is being collected? What would you do with the structured, semi-structured, and structured data that is coming to you? Oh, well, this is the time, and this is where big data will play a role in terms of all the various different characteristics of the data. And that is where we need to little bit know about the nuances of various different terminologies. Let's start with big data. It is the huge data volumes that cannot be processed by itself. Desperate databases, desperate data sets, and desperate data sources have to be combined together to analyze and making sense of that data. So don't focus on the left thing, we will come to that. Focus only on the big data and the machine learning. And now that I have so much of data, how will I actually make some meaning out of it? We all talk about data and big data these days, and data being the new oil, right? it's no more oil. I don't consider data as the new oil. I would say data is the new water. Data is the new oxygen. It is that paramount, and the importance of data is something for us to actually understand, rather than just looking at it as one more piece or one more piece of the puzzle when we talk about all of these technological jargons. No, data is paramount, yes, but I'm just getting to the top of it talking big data because I don't have dearth of data. I don't have any challenges in finding data sets today, which was not the case 20 years back. And that's where machine learning would play a major role today to bring about the meaning to the data by deploying some algorithms, some logic, and some analysis to it through various different programs, which is nothing else but algorithms, various different ways in which I would treat the data, I would learn from the data, and I would use the data. And this is where data mining, data analytics, data analysis, and the entire data science world would play a role. This itself is a topic on its own, but keeping in mind the topic of, or the theme of this session, I would go forward and I would want to put things in perspective. This is where I would refer to the phrase, which is the whole is greater than the sum of its parts, actually makes meaning. Look at where big data is and where all other technical expertise or technical prowess that we talk about lies. While all of it are interconnected, the superset is artificial intelligence, which I would gain only when I start looking at all of those pieces of the puzzle put together. So my data science is going to play a major role in not only collecting, collating, and making sense of the data. And when I start collecting more data, that becomes big data, which would lead to bringing the nuances of the algorithms, which is my machine learning, and then using some of the analytics on it, which is artificial intelligence. Let's go one by one. Let's compare data science, machine learning, and artificial intelligence. We need to get this right before we go forward when I talk about some use cases. So what is data science? It is mainly, it processes or it uses advanced analytics to extract relevant information from the data. Oh, wonderful. Okay. So the analysis that I do on my data, whether it is small or big, would constitute or would contribute or would be part of data science. Wonderful. It involves wide range of analytics application, which helps us in decision making. Oh, yes. Okay. So it would decipher and bring about the meaning of the data, which is important for me to decide. Wonderful. It also incorporates some of the predictive modeling and statistical analysis using machine learning principles. Oh, wow. Okay. So data science has got some relevance to machine learning because it uses the machine learning methods or some of the functions or features of machine learning. Okay, wonderful. Let's look at what machine learning is in that case. Machine learning is nothing else but the programming prowess that we have all built of late over the last 40, 45 years. The algorithms that have been built, the programs that have been used, the tools that I use for creating these programs and algorithms are all part of machine learning. Okay, at its base of it, yes. But it forms the analytics in which the software program, and in this case, let's talk the software program as an algorithm, it learns about the data and find patterns or insights. Ah, this is interesting. So I'm using my software programs to learn about data, which means to say that there is some program that I would develop which would look at the data and start making some meaning out of it, which is mainly finding some patterns, finding some predictions, or finding something that probably we are not able to look through to the OLAP and the OLTP things that we were doing in the past. Okay, finding pattern. Okay, finding pattern is something like connecting the dots. It's like coming out with a mathematical equation and proving it. And all of this would be done through some algorithms that are already existing and some algorithms which we would invent going forward. Right? Okay, and it includes a combination of supervised, unsupervised, and reinforced learning methods. Okay, now the machines are learning while we have stopped learning. Is that so? Oh, well, probably yes. I remember a meme sometime back seeing it, saying that machines are learning and humans are hooked. Yes, we are hooked to something that the machine is providing me without me looking at it from an analytical or critical thinking aspect. We will go to that later, the human aspect of it, which is not the purview of today's presentation, but it definitely drives. Now that we have spoken about data science and machine learning, and we see something about learning and different models and all of it, let's see how machine learning and artificial intelligence go hand in hand. So what is artificial intelligence in the first place is that it's the development of the computerized applications. Yeah, there are a lot of applications that we have developed, right? Yeah, a lot of programs, a lot of algorithms, a lot of applications that are being used by corporates, by enterprises, by various different institutions and individuals like you and me for my day-to-day work, which that stimulates human intelligence and interaction. It has to stimulate human intelligence and interaction. Okay, so artificial intelligence is a tool at a very simplistic way, or a simplistic manner if we have to put. It's nothing else but an extension of the computerized applications or the algorithms that are available to me to provide a better human interface. Okay, that is where the ethical artificial intelligence comes into play. It handles specific tasks, which is mainly something repetitive is done by machine learning. But what is artificial intelligence to do? It generates some intelligence by looking at the data, bringing about some pattern. And that pattern could be not just by connecting the dots of the data, it could be something to do with vision, computer vision, or it could be to do with a lot of analysis from various different consumer behavior and aligning it with cognitive capabilities. Now, cognitive capabilities is the thinking abilities which only humans have. Not really. Most of the living beings have, but humans have it the best. So, are we going to create something from a machine which would have the capability of thinking like us, and going forward, it would do a lot of these mundane things and the thinking capability works also which we humans do? Oh well, this looks to be a little dangerous. If at all that's the case, then what are we humans going to do going forward? My mundane things, repetitive things are all being replaced by machines because of automation and robotics. If the cognitive capabilities are also replaced by artificial intelligence, what are we humans going to do? Scary situation, isn't it? Well, not really. At least not for the near future. Of course, there may be science fiction and fantasies of robots taking over us and humans being destroyed and stuff like that. Probably yes, if we don't use the ethical artificial intelligence concepts, probably we would destroy ourselves. But that's distant future. We don't have to worry of it now. For the time being, we need to worry about how we build and extend and expand the machine learning and artificial intelligence. And let's look at it as an opportunity for all of us as technocrats, as engineers, as academicians, and as students of computer science, IT, automation, electronics, and communication, and all of it. It is a big, big opportunity. So artificial intelligence uses the algorithms for machine learning, natural language processing, automation, and more. Okay, this is already known. So let's go a little forward. Okay, let's little complicate things. The very essence of artificial intelligence It's a software systems that learns based on the input. Oh, this is like input, process, output. Oh, well, that's the base of any computer science, any programming language for me. Okay, yes, we have extended it. Probably we have named it different as artificial intelligence now. Oh, is it old wine in new bottle? Probably yes, but a better wine in a better bottle, and not necessarily something old, but yeah, something new also. Oh, that makes it interesting. So what is it? So let's start looking at all the various different components that make up artificial intelligence and various different use cases that we can look around us. Even now, as I speak, you can look around and see many of this being in use. So all the previous slides which I just spoke about, which is deep learning, whether it is supervised or unsupervised, are all classified as machine learning, which also aids artificial intelligence. Now, when we talk about the NLP, the natural language processing, we talk about content extraction, classification, machine translation, question answering, and text generation, which is also some of the things that we would look at when we talk about artificial intelligence. We talk about expert systems. Oh, wow. Expert systems is something that would be dealing with providing the necessary information and necessary intelligence for decision making. Ultimately, it is the human who's going to decide. The machines would decide at a very, very micro level, not at a macro level. Because at least now and for the distant future, not all of this would be consolidated, or not all of this would be working in tandem. They are still working in silos. So it's going to take a long time. Now, added to that, if I bring about computer vision, which is image recognition and machine vision and computer vision, all of it, it complicates the matters even further. It is like just looking at the data, which is just alphanumeric and some special characters. It's easier for anybody to decipher. When I start looking at vision and training a system to recognize the different ways in which the same thing can be viewed is a major challenge. That is intelligence, which we humans, or rather for that matter, many of the living things already have, which is inbuilt. Whereas the machines have to learn from scratch. And we need to teach them the way they know or the way they learn. So the other thing is speech to text and text to speech. This is like proliferated into our daily lives. I have speech to text and text to speech apps on my mobile phone. So I could use it for anything. Instead of typing, I just talk it out, and it converts my speech to text, and I just copy paste it into my documents. It's as simple as that. Speech to text and text to speech. I have text, and I have many simple applications which would create the speech out of the text. But what misses out is the annotation, the intonation, the pause, and all of it, which again needs improvement. And that is where we talk about the speech recognition and the speech enhancement. And it becomes easy when it is English. Test it out on Indian languages. That would be a big opportunity. If I were to bring about the text to speech and speech to text for all Indian languages, and in the meantime, translate it as well into any of the languages, probably that would be a big project. And mind you, CDAC and other Indian agencies are already working on it. They are far ahead of many of the other international companies, but it being focused on Indian languages, the usage would be limited to India. But going forward, it would also be used by others to actually make sense of the various different languages that we have, especially the literature or the rich cultural heritage that is within every language, which is within every Indian language. So big opportunity for all of this. And of course, robotics and all of the other things would be part of artificial intelligence going forward. So The fusion of three different technologies is what is driving. What is driving the future and what is driving the decision making, the data availability, and the knowledge is the three things that I have mentioned here. Advanced wearable products. The wearable products are an extension of IoT, basically, right? Artificial intelligence platforms. Oh, yes, you talk about it and you would have thousands of them. We'll look into it. And then big data, of course. When I have wearable data, wearable products, each one of us is wearing at least one wearable product today, or at least carrying one, if not more. Your smartphone is one classic example. Artificial intelligence platforms play on your data. They need data as their input. So when we talk about wearable products and IoT, there is huge amount of data that is getting generated. And that is exactly what is the feeder system for my artificial intelligence platforms. And that is leading to a boom in the big data. Big data, artificial intelligence, and IoT all going hand in hand, which is mainly converting data to actionable knowledge. I keep giving this example when I keep talking to a few of the data science experts. I take an example saying that 20 years back, if a person was able to tell me the 7 wonders of the world, we used to call that person very, very knowledgeable. Well, yes. Today, if somebody tells me the 7 wonders of the world, I don't call them knowledgeable. I would call them well informed. That is the change. Please mind this particular change that has happened, which is very small, minuscule, but that is what is changing the whole world. The thing that was knowledge of the past is just an information of today. And the information of today is going to be data of tomorrow. So that is where we are leading to. And thanks to the technological advancements, thanks to the technological nuances that we are employing, deploying, and using it on a day-to-day basis, it has become so very easy to access data, access information. But what we do with that information is what is intelligence and knowledge today. And that is where we would have all of these platforms and systems to support us, but there will be no replacement for the human brains, provided we remember Darwin's theory of use or lose theory. If I use my brain in the right way for using all of the data, all of the information to put into actionable knowledge, I'm using it. If I don't do it, if I'm over dependent on the systems that are being built, the platforms which we speak about, artificial intelligence platforms, if I'm just going to consume that, I would definitely lose my intelligence going forward. So it's a double whammy. I have no choice than to go this route, but at the same time, hold on to the basic cognitive capabilities of human beings. So let's look at the wearable market. Now, what is this? This is huge. Well, why I'm saying it's huge? It's because wearable technology, especially after the pandemic, this data is a little old, pandemic data maybe even more. 71% of the 16 to 24-year-olds want wearable technology. Oh, wow. Okay, that means the Z generation and the Z plus generation are the ones who are going to use it to the hilt, use it to the maximum. And that is what is leading the market to look for platforms, methods, ways, and means to analyze all of this data that is being generated. So according to Global Web Index, 64% of global internet users have worn a piece of wearable technology already or are keen to do so in the future. So 64% of the internet users, and the internet users are increasing as we speak. All of these are numbers, and Forbes and other folks are actually working on it. So what? That is what is bringing about the connected world. artificial intelligence, which brings about connected data analytics, connected data intelligence for bringing about the meaning and providing each individual, each citizen on the planet Earth with livability and an opportunity to grow and thrive. Okay, now look at the market. Look at the various different portfolios, various different technologies that artificial intelligence is actually making way into new businesses, new companies, and the number of different aspects that the companies are focusing on. So machine learning, general machine learning, there are 123 companies already working big time into this. There are 260 companies who are working in machine learning applications, 106 in the computer vision app, smart robots, NLP, virtual assistants, speech to text, speech to speech, recommendation engines, gesture controls, video content recognition, which is again part of my computer vision. So look at the various different applications, various different segments that artificial intelligence is playing a role in each of them. It's huge, it's big, and the registered companies across the globe who are seriously working in artificial intelligence is in thousands. So having said that, let's look at the industry segments in which they are working. Healthcare, off late, this is the most sought after industry segment, especially after the pandemic has hit us. So post COVID-19 scenario, there is huge investment and focus on the healthcare segment. So segments of healthcare, finance and insurance, of course, yes, transportation, construction, retail and warehousing, government and city planning, which is mainly smart cities, media and entertainment. Oh my goodness, talk about it. We have all been glued to the OTTs, the platforms that provide us entertainment, right? And of course, education is also changing, manufacturing, legal, agriculture. You talk about it and it is making inroads. And the artificial intelligence 100, I picked it up from the CB Insights. You can go online and search for it. CB Insights provides you with a lot of industry specific and generic information, especially when we talk about technical aspects and technology that is changing the world. Cross industry technologies, what are we talking about? We are talking about AI processors, artificial intelligence processors, which is mainly getting into the brass tacks. When we talk about brass tacks, it is mainly the silicon technology, which is what we use for compute. The compute power comes from the processor. So we're talking about building in artificial intelligence processors already, not necessarily just for compute and communicate, but an extension of that would be artificial intelligence processors. The NLPs, the computer visions, and all of it, which we all know, BI and ops intelligence, and a lot of research and development happening across for bringing in efficiency, for improving productivity, and for bringing about new use case models into the market. Wonderful. Let's go a little deep into knowing what are the use cases, and let's combine artificial intelligence, machine learning, and big data. At a macro level, I would not differentiate any of this. But at a micro level, yes, I will have to. And why is big data important is because of the amount of data being produced. Look at this. Now the internet is producing 20 quintillion bytes every day. Oh my goodness, 10 to the power of 18 bytes per day. Probably this has increased. This data is that of just when the COVID has hit us. So probably this would have surpassed. But nevertheless, the crux of the matter is that this data actually includes textual content, which is structured, semi-structured, and structured again, unstructured, of course, and then introduction to multimedia content. Now, this is what is building the complexity. It's not just the text. It's not just the images, it's not just the audio, it's the video also, which is part of the internet data or the growth in the data that is being produced and consumed, and on various different platforms, whether it is for enterprises through the ERP solutions or the social media, which is a big thing that's happening, and sensors which are being used by the industries. So all of this put together, let's go to some of the use cases. We spoke about all of this. The first use case that I'm bringing about is a smart city framework. I'm not going into the details of uh, what a smart city is, but how technology is enabling smart cities is to improve operational effectiveness. And that's where we can see that the lives and properties and the damages are being reduced when we know that there is some natural calamity that's going to happen. You may ask me that we couldn't predict a pandemic. Yes, it's the world over. That's the phenomena. Unfortunately, we couldn't predict because it is something still a matter to be investigated, whether it is man-made or whether it is natural. In either case, it was not predicted by anyone. If somebody has played a fool around, probably we'll get to know in the near future. And thanks to the technological advancements that we have, we will get to know of it sooner than later. While we are talking about pandemic, while we talk about smart city a little bit later, let's talk about the pandemic and the post-pandemic scenario. Just rewind a little bit back and see how much time has it taken for the world to come up with a vaccine for anything in the past, be it for a cure for tuberculosis, for polio, or chickenpox, or diphtheria, or elephantiasis, or any of the previous pandemics that have occurred, including plague. It has taken decades and decades and decades of hard work for coming up with a vaccine, and another few decades for it to be reaching out to the entire population of the globe. Sitting today, most of us have at least got the first dose, or some of us have got the second dose of the vaccine already, while we are just about a year and a half from the time the pandemic or COVID-19 was known to the world. How do you think this happened? This happened because of technological advancements and the use of advanced machine learning and artificial intelligence to simulate and test the vaccines to be rolled out in the fastest manner. The turnaround time has been the fastest. I've been talking to a few of my friends in the healthcare industry and also a few scientists in the pharma industry. And it is the access to the data that has made the difference in faster turnaround time and faster collaboration with humans to improvise and to improve the efficacy of the doses. Now, of course, we are still learning. The whole world is learning, but look at it and compare it with how technology, especially computer science, data science, artificial intelligence, and machine learning has helped in bringing about the vaccine into the market as fast as probably a year. Right? Okay, so having said that, let's come to the smart city framework. It is to improve operational effectiveness. It is to create opportunities, promote flexibility, and reduce the risk. And how is technology helping us? I'll tell you how it is. This is how it helps. Data from any device gets collected, collated, consumed, and computed. Cross-domain information gets collated. That is when I connect the dots. It could be from smart lighting to smart water to smart flood management to smart traffic management to a whole lot of other things. And then having an access to the open ecosystem wherein I would have the APIs and other various different applications talking to each other. So at the base, I am talking about core data engine which would talk to various different systems and bring about a meaning to all of that data, apply some algorithms, apply some machine learning onto it, identify some patterns, and then make use of it through a dashboard for the decision makers to decide what is to be done and how. Right? Now look at something like adaptive traffic management, which some of these smart cities are thinking of implementing, wherein you would not be waiting at any traffic signal for more than a minute, even in the busiest of the busiest time. If that could be implemented, that would be the best thing to happen when we talk about commuting in cities and increasing the traffic as we go ahead. Okay, IoT and AI architectural, I'll just demonstrate what I just spoke about. I want you to think about the various different elements that go into making a city smart. And IoT, ML, AI, and big data are playing a big role. And integration is the key. Now, when we talk about integration, that is where artificial intelligence and machine learning would play a role. And of course, data is the key for all various decision sciences, data aggregation, analytics, dashboarding, data visualization, and decision making. So I will just go ahead of this. Okay, now coming to computer vision. We have all had CCTVs installed in various different cities, into various different buildings, and all places that we go. Now, what is happening? If you look at the picture, you have feeds coming in from thousands and thousands of CCTV cameras for surveillance. And what are these two guys doing? They're not even watching at it. Naturally, humans are not programmed to be watching or staring at a screen for a long time. And that's true for all of us as well. We are not staring at the screen all the time, are we? No. What would happen if I miss out on something crucial in terms of an intrusion, in terms of a theft, or in terms of an attack? And if these guys are not looking at it, I miss out. Yes, if these two guys, or even if there are 100 guys, there is a chance of missing. And when we have humans, there is a chance of missing out, which is but natural. So this is one more area or one more segment which has huge potential for deploying machine learning and artificial intelligence through computer vision. And there's a lot of research that has happened, which is being used. So this is one aspect I wanted to talk about, the smart cars. From smart cities to smart cars. Gartner had said that by 2020, 1 in 5 cars on the road will be self-aware. Probably it is still not happened, but to a large extent it has happened. Let's look at it, which will be able to discern and share information on their mechanical health, their global position and status of their surroundings. Oh, okay. We're not talking about an entire completely connected and automated autonomous car. What they are saying is 1 in 5 cars on the road would have the intelligence system built into it, which is true even today. Most of the cars purchased in the last 5 years would have some intelligence system incorporated into it, which would help us in sharing the information on the mechanical health. So my service station would exactly know when the service is due and if there is any problem with any of the parts in my vehicle, which is true even today. So how has this happened? This has happened because there is a lot of intelligence that has been built through some of the IoT sensors and some compute and communication devices that have been put into the cars. That is what it says. A system of sensors, vehicle-to-vehicle communications, and computing power will lead to intelligent cars that interact with their owners. So each car comes with an app these days. And I would be able to monitor the simple things of the quality of the oil, not just the level, but the quality of the oil, and probably the time from today to the time that I would need to change it, predictive maintenance, and stuff like that. Look at the numbers. The connected cars to the non-connected cars. The connected cars are almost 3 times that of the non-connected cars today. Global estimated connected cars shipment is close to 100 million, but we are talking about 69 being connected cars. 69 million, 69% of it being connected, which means to say that this is the future. And look at this. Self-driven cars could generate 1 gigabyte of data a second. Oh my goodness. This is something which is an opportunity. If my car, self-driven car, wherein I just sit and it takes me to the destination that I have told it to, it would generate 1 gigabyte of data a second. Oh my goodness. Probably if I go on a distance of 20 minutes, you do the math and you know exactly what is the kind of data that it has generated. And this is leading to the artificial intelligence startups and the artificial intelligence companies coming out with ways and means in making sense of the data that is getting generated. This is what we call big data on wheels, right? So we're going to use this for a lot of online activities. So per hour, vehicle data generated could be anywhere between 25,000 megabytes. And what is it all going to? Music streaming is large. HD video streaming, oh my goodness. So it is not actually something which the machine is generating or the car is generating. It is what the folks within the car are consuming. So look at it. This is again a big opportunity, a big use case model. And this leads to, okay, the same thing. Yeah, sorry. This leads to ways and means in understanding the way the user behaves. This would lead to consumer analytics. I have that also to present depending on the time availability. I can take that up as well. But before going to that, I would want to talk about the connected health. This is something that I was part of when I was with Dell EMC. The big data cure is talking about preventive and predictive healthcare by having app-based or sensor-based monitoring and controlling of the health of individuals. So physical examination and vital signs and all of it being monitored on a continuous basis, especially for chronic disease patients, for post-operative patients, post-surgery patients, for reducing their hospital stay and hospital cost while getting treated, even while on the move, not necessarily only at home. So all this proliferates to creating the complete ecosystem of data collating, collecting, consuming, and analyzing. Let me talk about something that we have all been using extensively over the last year or so, especially after pandemic, the massive open online courses, which is MOOC, an acronym which is the MOOC. We're talking about 35 million users, or rather, at least they have access to at least one or the other course. It is doubled from what it was last year, thanks to pandemic, thanks to people being glued to the system. But why am I even talking about it? I'm going to talk about numbers. We're talking about numbers to the tune of each one of them I've just taken up. So you have the Udemy, the Coursera, the Udacity, the edX, and a whole lot of other folks like Allison and OpenSAP and all of them coming on board. But look at the number of users, the jump in number of users from last 2 years. We're talking about 76 million users on Coursera alone, followed by edX and Future Learn and Class Center. Look at the number of universities that have jumped into the bandwagon. 950 universities across the world have come on board. 180 million students have done at least one or the other course. And all of us are part of those 180 million students, mind you. 16.3 thousand courses, 1,180 micro credits, and 67 MOOC based degrees. These are online degrees altogether, not just certificate courses. These are online degrees. Now, talk about it. Look at the increased demand, the jump in the demand in 2020. Why? That's because we all were glued to our homes and glued to our systems. Now, why am I talking about this? I'm talking about this because of the number, nothing else, the data. What am I going to do? And what is Coursera going to do with this data that they have of 76 million users? Well, I would start looking at doing some consumer analytics onto it. I would want to know the behavioral pattern of my users. I would want to know what are their interests, what could be their potential interest, and what could be their potential courses that they should be exposed to. Now, big business opportunity. That would lead to my consumer analytics. But before that, we talk about content everywhere with no contentment. Yes, I would want to leave you with some thoughts on the content that we generate, which is user generated content. I generally say UGC, not I, it's an acronym. But in India, UGC has got a different connotation. Well, so be it. But when we talk about content, it is the user generated content which is more authentic and trustworthy than the media that generates and talks about it. Why is this important? Is because social media is on the rise and there is no stopping. So we are all creating and consuming at the same time. And what are we doing? We talk about product or brand conversations with friends and families. 74% of them do that. Now I'm going to the recommended system after this. But prior to that, I will also talk about the consumer analytics. So user generated content helps in analyzing the consumer behavior and looking at the patterns which would be used for selling more products or upselling the existing products. So that would lead me to asking some questions before I go to consumer analytics and recommender system use cases. Where are we on time? Okay, so how much more time do we have? Do I have another half an hour? 20 minutes? I would go by what you say. I would rush through each of it depending on the time. And that's the artificial intelligence I'll put into my system. Just kidding. Let me know the time and 20 to 30 minutes. Okay, fine. Let me pick up some few questions that have come in here. Oh, wow. Okay. Right. Okay, 20 to 30 minutes. Can you elaborate on trustworthy artificial intelligence? Okay, very good question. Let me take it up after I finish off with the topic. So just give me a minute. I will pull up my presentation. Yes. So this is what it is. Okay. Okay, now this was a presentation I did very recently when I was doing it for my Society for Data Science. Yes, consumer analytics using data science. Let me just stop my video to ensure bandwidth, good bandwidth. Okay, so consumer analytics, let's look at this. Okay, continuous industrial transformation is what we have already seen, which is brought in transformational supply chain management, just-in-time supplies, and a whole lot of improvements there. What we are talking about is the third platform, which is the SMAC being put to use. The social business, the mobility, the cloud, and the big data analytics, which is again a conglomeration or a combination of all the various different things I have spoken about. But what's important is data everywhere I have spoken about. And if you observe, I'm talking about not just it to be as a software or a hardware, it is data everywhere. Yeah, yeah. So that is where they are. Okay. Now coming to the consumer. Consumer behavior is something that marketeers and product owners and new entrepreneurs are always on the lookout. And what is it basically? Consumer behavior is a very complex matrix which is driven by a lot of factors. And what are those factors? Society, your own personality, the culture that you come from, the background, your attitude, your economic status, your family, your educational background, your demographics, and a whole lot of other stuff. Oh my goodness, it is very complicated. Yes, for a non-machine learning concept, this is very complicated. But for machine learning and a data scientist and a person who knows artificial intelligence, this is just a play of numbers and data, basically. Okay, very simplistically put, but look at it that we need to go into the details. I'm just taking up a example. Okay, I'm going to do some analysis on the sales. See, ultimately, it's all about sales and numbers and how profitable I am when I launch a product. So I want to know how my product, how is it being sold or how is it being taken up. So it's a simple formula. Sales is equal to total number of households into the penetration into the buying rate, for which I need to know the total number of households, which is just a number. I need to deduce the penetration and I need to know the buying rate. So I would exactly know these components, which are basically from the market. So what's driving the sales of my brand? Two things. One is how many households are buying my brand, which will define the penetration, and how much is each household buying, which is my buying rate, right? How much is my product being bought, which is buying rate, and how many of them are being buying it is the penetration. So I finish off with A and B, and then I come to C and D. How often does each household buy, which defines my frequency, and how much do they buy in each trip, which is the size of the purchase, which is the sale per trip. Now, if I deduce all of this, I start getting numbers. And when I start getting numbers, it becomes an easy game for applying a machine learning algorithm onto it and bring about the knowledge or the intelligence around it, right? So, but it is not that simple. I need to look at various different aspects when it comes to human behavior. Now, many of the buyers would have various different ways of looking at things. So we need to look at the significance and the involvement at the same time. Now again, okay, this is a 2x2 matrix. So when it is a 2x2 matrix, I can definitely put some numbers to it and make sense to it and bring about a meaning through ones and zeros. Yes, wonderful. Habitual buying behavior, I give some number. A dissonance reducing buying behavior, I give some number. Complex buying behavior, I would need some more some more deep learning there. So I would keep it aside. Variety seeking buying behavior. Oh, okay, now I know. So depending on the significance, the difference, and the involvement, I would come out with a algorithm. Algorithm may sound uh, a little what to say difficult. Let's say it's a program basically. I would deduce a small simple program which would make sense of if it is high involvement and what to say low difference. Then there is a way in which a buyer would behave, but it also depends on what the buyer wants to buy, right? So this would mean that I would have to deploy some complex machine learning algorithms. And what could that be? It could be looking into all the factors influencing consumer behavior: economic factors, personal factors, psychological factors, cultural and social factors. Now I would make all of this into a matrix, and then I would have multiple matrix going and figuring out what suits the best. Okay, now I would not go this is okay, done. Understanding all that is fine. Okay, now what am I doing is I need to collect the right amount of data. Look at this as a use case wherein an artificial monitored store or a mall would start collecting the data from the time you enter to the time you spend at each of the aisle in front of each of the product, picking up some of the product and looking up to the details. See the micro level detailing that an artificial intelligence system can can look into for collecting the data, which will be fed into my machine learning algorithm. And then the recommender systems would start playing their role. And what are recommender systems? It's basically to provide you with suggestions, with options, and some inputs for you to decide as to what more can you buy, or whether you should buy this or something else, because you would save some money if there is an offer, right? All of these things we have experienced. So while all of this is happening, the predicting consumer behavior with data analytics is a big thing these days across all verticals, not just retail or not just for any consumer goods. It is for anything and everything that we speak about. Thanks to technology and thanks to social media that we could go in. I would not get into the details wherein what all would the system need and how they are doing the analysis, taking into account the various different data elements and points, whether it is in store, whether e-commerce, or whether it is combining it with the supply chain and logistics, or on demand supply that is needed, or it could be a mom and pop shop around, or selling through different apps and stuff like that, which would bring in a lot of data points from various different sources in unstructured, semi-structured, and structured manner, which could be simple or complex. And that is where the big data analytics would play a role, right? So I will not get into this. We are talking about eliminating over $100 billion of coordination waste. Look at this. If I look at big data analytics, mobility, and social business all put together, it is going to eliminate the coordination waste to the tune of $100 billion across the world. That's quite a bit of saving. And why not? Why should I not look at it when there is a benefit, right? So sales and CRM, manufacturing, customer recognition, supply chain, payments are all automated. They're all done at one go. And technology has all combined to help me with this. Now, having said this, again, this I've already spoken about, consumer behavior models, which have been there in the past, have been automated today by using some of the machine learning models, machine learning algorithms. And to name a few, Horvath Seath model or Nicosia or stimulus response model are all automated these days, which work wonderfully well when I feed in with the necessary data that I have. So artificial intelligence, machine learning helps in various different activities here, whether it is for discovering, exploring, buying, asking for feedback or recommendation, using the data, or engaging with the end customer, or advocating, which is mainly in terms of advertising, branding, and building the loyalty. Look at the complex nature of the buying. We had not even thought that it would be so very complex, but yes, if you look at consumer behavior, it is complex. Now, what do I do with this? Well, first I need to understand and then start applying various different models. The unified attribute model, it would combine the customer data models, the content model, the product data models, and of course the knowledge architecture, which keeps building and which keeps refining and which keeps learning in every transaction that happens. So the knowledge architecture is my artificial intelligence system, which I have deployed on the consumer data models, the product data models, and the content models to learn on its own, depending on how the various different data elements are behaving in various different scenarios. Easier said than done, but thanks to the advancement in the application of the machine learning algorithms, which help in bringing about the right insights and providing the right data for information and knowledge. Look at the various different places from where the data comes in. I've already spoken about it, and I've spoken about this as well. I would share the presentation so you don't have to worry about that I have rushed through this, But the intention is that I go to the recommender system and look at how machine learning and artificial intelligence systems get built and how they would be useful in the scenarios that I have spoken about. So I will stop presenting now for a moment and look up to, oh, okay. So, sir, suitable examples for big data relevant to AI. Yes, okay. I'm doing that. How to become member of Society for Data. I'll let you know on that. Yes, I'll take this up, but let me finish off with this last presentation of mine, which is mainly in terms of the recommender system, which is the crux of all the thing that we spoke till now. Another 10 minutes and I should be done. Yeah, so give me 10 minutes and I should be done. I will, yes, I'm just presenting. Yes, so this is what it is. Yes, recommender systems. There are two basic approaches to recommending. Well, this is not rocket science. This is age-old thing. One is collaborative filtering, also known as social filtering, and then content-based. Content-based is something we all know in terms of what we want to buy uh, is content that is thrown to us. Systems for recommending items, I'll just pick up a few examples. It could be books, movies, CDs, web pages, news groups. It could be anything. And these days, it's all about Netflix and Amazon Prime and all of it, right? So I'll take some example from there. Based upon the preferences and the preferences that of the end user. You and me are all end users for all this. So we are using a lot of recommender systems, knowingly, unknowingly, but after this, you will exactly know how it gets implemented. So many websites provide recommendations to all of us, which we all know: Amazon, Netflix, Pandora, Amazon Prime, Flipkart, all of them. Recommenders have been shown to substantially increase sales at online stores. Okay, this is some study. Wonderful, fine. So how do we actually start implementing the recommendation or a recommender system? Recommenders are instances of personalization software. There is personalization. We have moved away from customization to personalization in the last decade or so. Personalization concepts adapting to what is it? What is personalization means? To individual needs, interests, and preferences. So basically, we are going back to consumer behavior, components of consumer behavior, components of consumer attributes, which is needs, interests, and preferences, which also includes, in the sense, the recommender system or personalization includes recommending, filtering, and predicting. Oh, wow. I'm not only doing recommending, but I'm doing filtering also for the user, which is good. I don't have to go through thousands and thousands of listing for me to pick as to what I should be looking at, right? So, and I watched something initially on Amazon Prime. For the first and the second time, there couldn't be any recommendation, but from the third time, I would start getting some recommendation. How has this happened? It would pick up from various different algorithms and artificial intelligence system that is working in the back end. So we'll get into the details, but from a business perspective, it is viewed as part of the customer relationship management. Wow, wonderful. So my customer relationship management, it is getting automated at the back end. I don't need a person to actually be interacting with the customer or the consumer as of now, which is good. Okay, but we need to look at machine learning and personalization as to how this gets built. Machine learning can allow learning a user model or profile of a particular user base. We spoke about data model, we spoke about the product model, we spoke about the user model in the previous presentation. So it picks up some sample interaction and rated examples. Somebody would ask you to rate the product. Somebody would ask you to rate their service, right? So depending on the rating that you give and depending on the feedback that somebody would have typed in, there could be some recommendation systems. For example, when you go on to the Play Store, you would download some of the apps only if the rating is 4.5 and above. Only those apps are trustworthy if the rating is 4 and above. right? All of these systems need to be built at the back end using some of the basic principles like what we are just speaking about, right? So this model uh, or profile can be used to recommend items, filter the information, and also predict the behavior of the user. Okay, wonderful. Now let's get to the basics. A personalized online store, right? Now this we keep seeing frequently bought together. Now, when I go to buy something, there is a recommendation saying that when you buy this, many of the users would also want to buy this. So frequently bought together is depending on some of the learning the system has done looking at the pattern of the buyers. If majority of the buyers have the same pattern, this recommendation would come to you if you have bought one of those items saying that frequently bought together, right? Okay, now something beyond that. Customers who bought this item also bought. Oh wow, there is some recommendation coming in, some filtering also coming in based on your preference as well as the learning from similar preferences of others. It could be product based or it could be user based or a combination of both. Okay, now it is getting complicated. Let's go together, right? Now, a personalized online store, what they say, what other items do customers buy after viewing this item? There is this recommendation and filtering, right? So data science, data mining. Now I'm looking for something. I just want to know about data mining, right? So along with data mining, it would also recommend whether I want to buy this or not. So what is the recommender problem? Look at this. A good recommender and the challenges that it faces. And when we talk about a recommender, it's our program basically, right? So programming titles to a software engineer and baby toys to a new mother. A good recommender, right? So programming tiles. Now I know that I'm a software engineer. I would not be shown something about a mechanical engineering product. I would be shown something that would interest me while I do the search. And then of course baby toys to a new mother, of course. Now a new mother who's come online would be definitely looking at something to be used for the baby, right? And don't recommend items user already know or would find anyway. So that is something which I need to eliminate. While I'm building an algorithm, I need to keep all of these aspects in mind. Expand user's taste without offending or annoying him or her. There's a classic example. This is one of my manager used to tell me, and he was a Sardar, and one of the things that really annoyed him when he went on to uh, went into a mall wherein there was a recommender system that was that was put in place, and he laughed it out, of course, but it it could have offended somebody else if you recommend a shaving cream to a Sardar, right? It's a wrong recommendation. A simple example which can be hard hitting is it can't be hard hitting than this. I never use a razor. I never use a shaving cream or a shaving foam. So the recommendation, if it comes to him, what would that person do? He would just get annoyed and he would stop using that system going forward. Very, very important, especially in India, wherein we talk about multicultural, multilinguistic, multi-religion, multi so many things. It becomes very, very important that my recommender system doesn't offend anybody's beliefs, faith, religion, gender, affiliations, whatever. So if you could have a recommender system which can work in India, it could work anywhere in the world. So the challenges are, I did mention the challenges. Huge amount of data, tens of millions of customers data that is available, which you need to siphon off and bring something in. So a recommender system should adhere to the dialogue is, tell me something I don't know. मला काय माहित नाही ते सांग ना भाऊ. Right? So that is what my recommender system should be. So for doing that, I need to have the recommendation engine built up, and it would have all the various different components of web scraping, uh, customer data analytics, customer behavior analytics, consumer analytics, product analysis, the models, and of course the algorithm feature that I would bring in to collaborative filter or focusing on something else. So let me get into this. Two most widely used traditional algorithms are user-based collaborative filtering and cluster models. Content-based filtering or collaborative filtering, right? Content-based would be on the product and collaborative would be from user to user. So in content-based, it would be product and the recommendation in terms of consumers bought this along, and they would also be looking at some other product kind of a recommendation. But collaborative filtering would be like the book that you have read, your friend also has read it, or your friend also has bought it. So that goes to the next level of personalization. So this is something that we know of. Engine generates 35% of companies' revenue. As long as McKinsey's 2013 research, Amazon's recommendation engine itself generates 35% of companies' revenue. Now look at that. Now the same thing holds good for mostly my Netflix and some of the OTT platforms as well, I suppose. Right now, recommender system. Few more slides and I'm done with this. It talks about the item features, user features, which is what we talk about the user item matrix. So common types of data that we would look at is search for the purchase data, the past purchase history of the purchaser for doing some consumer analytics, consumer data analytics, and then look at some ratings and some comments overall, and then provide some recommendations that can go along with what is being presented. So my data, which is mainly of the user and the item, comes into my recommendation system, and I would put in some content-based collaborative filtering to come up with top pop, which means to say that the most popular thing comes up, right? This is completely non-personalized methods wherein the most popular thing comes up, which I may like or I may not like. So for example, the most popular movie comes up as a recommendation being watched by 10 million users, or sorry, which is watched and liked by 10 million viewers. Something of that kind would come up. I may not be interested. Now I need to get to the next level of probably being personalized. Now, to come to a personalized, I need to not only look at item features and user features, not just restricting it to user item matrix. I need to go beyond. But first, let's understand the content-based filtering that happens. So, for example, if the reader, or sorry, the user is reading an article, similar articles get popped up. The classic example is Google Scholar, wherein it gives you, may not give the exact ones, it may say similar ones, right? So which is mainly in terms of the content based, again using collaborative filtering, but this is a little bit hybrid wherein I'm combining not just the product, but I'm combining the user also. So that leads to the next thing. If I've combined the item and I've combined the user, I'm doing item filtering. Why can't I do user filtering as well? Oh yes, I can. So collaborative filtering of the next level would be not just on the item, but also on the user. So user preferences, item preferences, and then the recommendation. So it becomes a multi-matrix approach when we talk about the collaborative filtering for two elements here. Now, maintain a database of many users, ratings of a variety of items. Yes, now that becomes my data set. For a given user, find other similar users whose ratings strongly correlate with the current user. So I'm doing a lot of data analytics there. Recommend items rated highly by these similar users, but not rated by the current user. I have not rated it, but somebody similar to my buying pattern, my interest, my preference, my ratings has done something, so that would come up. I would do some analysis, and most of the commercial recommendations use this particular recommendation, especially Amazon. Now, collaborative filtering. Look at this. This needs little bit of logic here, which is mainly in terms of number of users, right? So I have a user database, and then I need to find out the correlation. So I have found A9 and A10, the first one and the last one, to have some correlation there, wherein the correlation is at the C. And now that I have found that there is some correlation, I would extract what could be the best recommendation for this particular user item combination. Now, if you look at the users, these are all different types of users. One is a mechanic, one is a rugby player, one is a tennis player, one is probably a miner, one is somebody else. So different user profiles, but having some common interest, wherein the user, the active user which is you, gets the recommendation when some of the correlation happens. So there is a lot of extraction that would be done on the user database for bringing about the correlation match as your recommendation through the recommender system that you have implemented. Okay, now if I go a little forward, I'll take one more example. Now I've gone into a little bit of detailing as well. Now user collaborative filtering, KNN based, the nearest neighbor based collaborative filtering. I find out some of these similarities, and then I go to find out the K nearest neighbors, aggregate neighbors, and then I would use some of the Jacquard similarity approach or cosine similarity or Pearson correlation onto finding out the best fit model that would be used for my recommendation system. Now, if I look at item collaborative filtering, it is to do with the products that I'm looking at. Okay, so in practice, item outperforms user in many use cases because items are more, users are also there, but comparison between an item to another item is easier because I have all the data elements and I don't have the additional data points of consumer analytics, consumer behavior, or which is something beyond just the features of that particular item, right? So item belongs to a small set of honor. Users have varied tastes, and item similarity is more meaningful than user similarity. So last sentence is what makes it easy for me to bring about item collaborative filtering. Very good. Now this is where it all comes. Item I have done, user I have done, user item also I have done. So in my data, I have a matrix of item features, user features, user item features. Now, when I bring about the combination of these three different elements from three different data sets, I would do content-based collaborative filtering of all of this put together to bring about some accurate recommendation systems depending on the various different factors that are there on the item and of the user, and provide some recommendation in terms of accuracy to a large extent. When I say accuracy, when you recommend it to me, not necessarily I will agree to it. So to the tune of probably 70-80% accuracy, user satisfaction, diversity, novelty, if I want to look at something different, which is novelty and stuff like that. And that would mean that I have implemented a recommendation system using a lot of algorithms on my machine learning, provided with a lot of data, which will self-learn when I have artificial systems incorporated, which would work in tandem, in collaboration with my algorithm, which would become unsupervised system going forward. Okay, now I would take up questions. Some of the questions that had come on the chat is, yeah, suitable examples for big data are relevant to artificial intelligence. I just spoke about it. I hope that was clear. Maybe I had to rush through, but paucity of time, I had to stop there. I had to rush through, but I hope there is some amount of understanding in terms of how it can be implemented in the day-to-day life that we are carrying out. And most of us are ordering everything online these days. So next time when you do some online ordering, you exactly know what is the recommender system, what is the consumer behavioral analytics these folks have done in the back end. Right? So that is where we are now. And for the question that Dr. Nitin has asked me, you can send me an email, or you can go on to s4ds.org, which is the website, and fill up a form giving my reference, because I'm the founder member there. We can expedite it. And by the way, it is also open for institutions and colleges to be part of the Society for Data Science in terms of getting the knowledge which we have collected and collated all these years, to proliferate it and pass it on to not only the faculty but also to the students going forward. So we could have Society for Data Science chapters in various colleges going forward, and we have already started in a few colleges in Pune, Ferguson College being one of them, and probably we can look at how we can collaborate on that. Okay, so any more questions? Yes, Sankirti madam, over to you. I'm done.
Thank you, sir. Thank you so much for such a, what I can say, wonderful session as usual. You have well depicted that technology cannot grow without business support. Rather, both are growing simultaneously. Even we have seen business to use case modeling throughout your presentation. So thank you so much sir, for your valuable time, and thank you, participants too. I conclude here. Today's session is over.
Yeah, thank you so much, madam. Thank you for the opportunity, and look forward to many such interactions going forward. Thank you so much.
Okay. Sir, in chat, people are asking for email ID. So, may I share it?
I'll type it if you're
sir.
okay. Yeah.
Okay.
Okay. So there you go. Bengeri@gmail.com. Very simple. Yes. Thank you so much.
Okay. Thank you, sir. Have a nice day ahead.
Yeah, and all the best for your rest of the day and rest of the sessions going forward.
Okay. Thank you.
Thank you, madam. Thank you.
Rathod sir, can you please stay back for 5 minutes?
Yes, ma'am.
Rathod sir.